Morning, everyone. Thanks for coming to this presentation. Hope you are enjoying Star Trek. My name is Ayan Dave, and I'll be presenting on this topic around Json Web Tokens. So I've been working with Json Web Tokens for around 6 months now. The topic really started for me 8 months back, actually, when we had to design a new REST API, a new system, a microservice, top-down, and we didn't really want to go with a cookie-based system. We wanted to secure our endpoints and make them available to many different kind of consumers, JavaScript, Ajax-based, browser-based applications, or even native apps, or anything else. And we were looking for something better than cookies at that point, and that's how we started looking at Json Web Tokens. So that's really where this topic came from. After 6 months, we've been using it successfully now in very good ways. So I thought it's a good topic to share with everyone. So a bit about me. I work with Fusion Alliance. Previously, we were Quick Solutions right here in town. You may know us by that name. I work as a Java competency lead there. And I say Java, but really my team works, and we all work in a lot of different technologies, .NET, Java, everything on JVM, UI, JavaScript. So we are also looking to add a lot of engineers to our team. So if you guys are curious about what we do and want to talk, see me after this session, or my colleague Mike Meadows, he's presenting this evening as well at 3:30, so look us up. So in the next 50-ish minutes or so, I'm going to cover a few different things. The theme of this presentation is really two major topics. One is just a quick overview of what is a cookie, what kind of apps we can build with it, some of the issues that we run into with cookies. There's a laundry list of it, so I'm not going to go into every one of those. But a couple of things specifically that we were thinking about when we started building out this service, and how Json Web Tokens helped us there. And then the other theme of this presentation is absolutely the JWT, Json Web Tokens, right? That's what we are here for. So to jump straight into this, building applications with HTTP cookie, right? I'm sure most of us have done that. We have all done that. If you have not, it's an exciting technology. We should all try that out. It's really driven by this IETF specification 6562, RFC 6562. There was a precursor to that that came out in 2000s that talked about HTTP, the state management, and this is a newer, updated version of it. But this specification is about HTTP state management, right? And cookies are the default way, the prescribed way to do that. So what is an HTTP cookie? Right? It's a piece of data generated by a server, and it is saved on the browser side, right? So as simple as that, a string, a small piece of data. And now this browser serves up that cookie, that data, to that server every time a request is made, right? And now the server can pick this session ID or data, this cookie value out of it, and do some processing, do some lookup of additional session data or anything like that. Right. So as we look at the structure of a cookie, it's really a key value pair, right? And it has some attributes. So it has max age, expires, domain, path, secure, and HTTP only. These are some of the attributes that go with them. So max age really defines how long the cookie is valid. It's a number of days. It can be, depending on a use case, you can say that my cookie has to expire as soon as the browser closes, or in a specific amount of time after that. And there's domain and path that is set on that cookie as well to say that this cookie and the information in there is valid only for this one domain, not for other domains out there. The specification also lays out these two headers, set cookie and cookie header out there. So the set cookie header, it is used when the server side is setting that cookie data on browser side, and the cookie header is used on the round trip back when the browser is sending data back to the server. So there's a small example of that, of what a cookie may look like. I'm talking about JSession ID. This was created from a running Tomcat instance, and the value is just a string, and it calls out the path and domain. And HTTP only specifies that I don't want this cookie to be available if I do like FTP-based protocols or anything, and it expires at on browser close. Right. So just a bit more about what happens when this cookie exchange is happening. This will help me, lay a case out for JWTs in a few slides. So let's talk through that for just a second. So we have a server, we have a browser, and there's a database. Now I call it a database, but it can be really anything, right? It doesn't really have to be a physical database. It can be Couchbase or some temporary data store. What happens is when a login happens, the browser sends in the username password, hopefully over SSL. The server side will validate that username password, create a session object on the server side, keep that session data in this temporary store. It can be database, Couchbase, again, anything, and create an ID that goes with it. Right? This ID is now returned back by the server to the browser in the form of set cookie, and it says, here's your session ID. So that way, next time that request comes in from that same user, same browser, our server-side code can look up what was that session data. Right? That's how we build our stateless server-side architectures. Right? So this is when the next time the cookie, the request comes in, the cookie header is used, where session ID is sent back. The server side will retrieve that session ID and retrieve that data from, again, that intermediate store, do the processing, return that data back to the browser. And finally, when a logout happens, that's when the browser calls that logout method, URI endpoint something on the server side and says, here's my cookie. The server does the rituals of logging out the user, do any final data saves, anything like that, and erases that cookie on the browser side. Right? And when this erase happens, it just removes that cookie, or it may just send back a brand new cookie to specify that a new session has started. Right? So this is one way of how cookies are used. Typically, this is used. You may have built out different use cases with this. There are some problems, though, that exist out there with these cookie-based solutions, cookie-based workflow systems. Right? So one specific problem is that we are relying on this thing called a user agent, which in our case is a browser. The cookie specification, though, calls out the user agent specifically, because they don't say it's a browser. It can be anything. It can be some other piece of software, a library, or something that we may be able to use, which can be a user agent. Basically, anything that implements that cookie specification is a user agent. So here, what's happening is we are relying on this user agent. We have our server-side code. We have our application code, JavaScript, Angular, whatever code. But then we are relying on something else, which is not us. And we are relying on the fact that this user agent has implemented the specification in the right and the best possible way. Right? So in the past, we know IE9 did not implement max age headers because it was not part of the specs. But then other browsers did. And that's where user agent differences came in. Right? This also reminds me of an interesting thing that happened in one of our non-prod environments a few months back, as recent as 2016, where only IE was logging out users at a random, only in one specific environment. right? All the other browsers are fine, only IE does that. And we went through a lot of different ways of finding what is going on, logs and all that. And in the end, we found out that IE was deleting cookies at a random. And one of those cookies was a session ID cookie. Further research gave us this insight that the cookie specification says that each user agent has to implement minimum 50 cookies per domain support. And IE implemented it to the word. And it had exactly 50 cookies as a limit. Chrome and Firefox, they have much higher limits. They support up to 180 cookies or so, maybe slightly more than that, but something like that. Now, when IE was removing those cookies, there was no message on the console. There was nothing told to the user. Simply, the cookie was removed, right? So at this point, we are relying on the part where the user agent is doing the right thing. And we may run into issues when things like these happen, where we may not know how well is this implemented. Apparently, the spec was implemented very nicely to the word, but hey, how about some warning message, right? There's also a limitation, as a spec lays out, on the size of cookies, how much can be the total size of cookie that the browser should support at a minimum, and all that. So essentially, we are relying on this user agent, the browser in this case, but whatever other library we might use. The other issue with cookies is that it encourages this separation of designation and authorization, right? So the cookie session ID itself, it says that this one specific user is allowed access to this domain. But what within that domain? Every path, every URL, every possible URL with every possible get parameter on it. What is a designation that this user has access to? And cookies sort of encourage that separation, right? This is where we run into issues with third-party cookies and do not track and many other things. But that is the underlying gist of it, right? This can lead us to, or make us exposed to cookie deletion attack or any other kind of security problems. Like you can have a JavaScript which is just fetching all the cookies and it can simply go and delete them just the way IE did it for us, right? Accessing subdomains is also something that we run into. So what if I have my site at example.com and then I want to use an API hosted on something.com, right? Across domains or across even subdomains, how these cookies are used and accessed is a trick, right? So this is where the separation of designation and authorization is one of the major issues that we run into. Right? We rely on DNS and a lot of other infrastructure. Now, not directly, cookies don't need to work with one DNS or the other, but they have domain on it, right? So if I have my cookie on example.com, but if I'm hosting my CDN on, let's say, Amazon or Azure or some other place, how do I provide that cookie to these CDN servers, say, for example, to make sure that only this authorized user can access this specific piece of content, right? Or if I want to build a use case where if my primary server is failing, let's say example.com is where my APIs are hosted, and I want to build a fault-tolerant AJAX call that if example.com fails, go to this another one called some cryptic name.com to hit my APIs in case there's a DNS failure. Cookies won't work there, right? Because now that other domain won't have access to that cookie. Right. There's privacy considerations. Third-party cookie is a big one. I'm not going to go into details of that, but it's pretty popular. We have all seen it manifested in our apps in one way or the other. Right. The idea is really, though, about building stateless systems, right? We achieve building stateless systems on our server side by using cookies and many other forms. But now we have built an API or something that works only with these browsers that implement the specification right. If I want to now use my API from a native app on iOS or Android, or from a device, a thermostat or a fridge or something that can talk to these APIs, they may not have this cookie specification implemented, right? This HTTP cookie spec is an HTTP state management specification, right? So what is an alternative, right? A very compelling alternative is to use access tokens. I'm not talking about JWT yet, but just these things called access tokens, right? What is an access token? So this is taken from the OAuth 2 specification. The OAuth 2 spec, it calls out a lot of things. One of them it calls out is this definition of access token. And it specifically leaves out any details about the implementation of this token. It's much like an interface to class kind of analogy there, where it defines that interface, but it leaves out the implementation of that access token. But let's see this for a second, right? It says access tokens are credentials used to access protected resources. Right there, it is talking about the very one thing that cookies encourage, which is separation of designation and authorization. The access tokens bring them together, right? Credentials and your protected resources are brought together, right? An access token is a string representing authorization issued to a client. Much like a cookie, it's a piece of data, a string that is saved, which is the same, nothing different. The string is usually opaque to the client. Well, much like cookie, it can be. They represent specific scopes and duration of access. Just like cookie, you can have expiry of the token or max age kind of values on it. And these are granted by the resource owner, in this case by the server, just like the cookie again, and enforced by the resource server and the authorization server, right? So almost everything about access token is like a cookie, except that first line where it says it is authorization and protected resources coming back together, right? So that is an access token. Now, how is it used? That sequence diagram we saw before, how would that look like with an access token, right? So let's see this for example. This is a login use case. And the first thing we notice here is there's no browser anymore. There's application code and server-side code. There's your JavaScript code as the application code. Your AngularJS, JavaScript, React, whatever you're using, native app, anything, and there's server-side. There is no intermediary. There is nothing else that we depend on, right? So your app code will send in the username password again. The server will validate that username password. And just like before, it will find the data that is needed for that session. Now note here that there's no database as well. There can be. This is just one way of using access tokens, where there's no database, no Couchbase, no Redis, nothing, none of these temporary storage kind of things, right? You form or you fetch your session data and put it straight there on the token, right? Now, of course, you must be thinking about security. Hey, this data can be exposed. Yes, we'll come back to there in a second. But the session data is put straight on the token, right? Now, and this token is now sent to your application code, right? And this can be sent out using just a simple authorization header. It doesn't need to be any specific header. The spec or anything does not call what headers you use. Completely up to you, as long as your app code and server-side code agree to it, right? The application code now takes that access token and saves it. It can use local storage. It can be just a JavaScript variable or something, TBD, based on your use case. But it just saves that access token there. The next time any API call is going to happen from that JavaScript to the server side, you fetch that access token and send it back, right? So, and again, this time the authorization header is used. You can use XAuth token or any other header, right? But the idea is you take that access token, send it back to the server, and the server side does exactly the same thing. It extracts at this point the data straight from the token, the session data, does the processing, returns whatever data back. Right? At logout, the app code, all it has to do is simply remove that token. That's it. It has that token in local storage or JavaScript variable, just destroy it, and they're logged out. The app code may want to send it back to the server side just to make server-side logout process happen if we need to do any last-minute storage or anything like that. But essentially, your logout process is as simple as that. You just delete that token. Done. Right. So this is the idea of using access token. Very similar to cookies, although you're not tied or bounded to any specific headers. You can use any header you want. You're not tied to user agent, because now your app code is the one which is basically controlling everything. If you again think about stateless architecture, where you depend only on the inputs you are provided and nothing else, this really gets us there, right? Because we rely only on that input that was sent to us by our app code and not on user agent or anything. So what makes a good access token? It's about the structure of this access token now, right? It's simple to use. It's just a header, a string value sent over the wire. What is the structure of it? Do we want the structure of this access token to be very different all the time? No, right? There needs to be a standard around it. This is where Json Web Tokens come in. But a good token needs to be well structured, well defined, needs to be URL safe, so that we can send it over just URI parameters as well, not just headers. It needs to be self-contained, have all the information within, if possible. You can keep it out. It doesn't have to. I mean, you can keep session data out of it, but you can keep it within. You will keep all the expiry and path and domain kind information within the token, and it needs to be compact enough, right? So, because every app server will have some kind of limitation on what is the max it can process. So this is where JWTs come in. So JWTs are driven by the specification RFC 7519, right? And it is in a proposed standard phase, so it is all out there. Microsoft is one of the biggest contributors to this specification. There are some other companies and individuals as well. So what is a JSON Web Token? Right, what does it look like? So I've taken this screenshot straight from this site jwt.io. That is like your go-to reference to starting point to know about JSON Web Tokens. Right? But this is taken straight from there. And it shows three things here. The three distinct pieces of text. There's one in red, one in purple, one in blue, each separated by a dot. And there are meanings to that. What this JSON Web Token is in its decoded form is there's a header, there's a payload, and there's a signature. So that red piece on the left side in the encoded form is the header, separated by a dot, then comes the payload in purple, and then comes the signature in the blue. Okay. The header is basically a JSON structure with specific key value pairs. The ALG and TYP, algorithm and type, are the key names as the specification calls them out. And we'll talk about it a bit further. But it's basically just that. And it is base 64 encoded to form this string. Now, there's no encryption. There's no signing. It's just simple base 64 encoding that's happening, right? So not much secure here. The payload is also base 64 encoded. It's basically a JSON string. It's a JSON Web Token, of course, so it has to be JSON, right? But then there's the specific key names like sub, which is out there, and then other ones like name and admin, which JWT calls as your like public tokens that you can use it anywhere. But again, this is just base 64 encoded. This is the payload is where your session data or any app specific data goes, right? Not much secure, nothing about that here, right? But then comes the signature part of it. The header is base 64 encoded, plus the payload is base 64 encoded, and then we generate a signature out of it, which is again something we do base 64 encoding on, and we get this third part of the string. Right. So essentially, it's a combination of three things: headers, payload, combined together, giving us that token. Then we create a signature out of it. This means if you are using this token, and if you if you see that someone has modified the header or payload part of it, they tampered with it, an attacker or someone, your signature won't be regenerated, and that's how you can find out if that token was tampered with. Because the signature was created from a combination of header and payload. Right. So the important thing here is, since it is base 64 encoded, it is URL safe. You can use it in headers, you can use it in URIs, anywhere. And again, it is signing, not encryption, that happens here. Right? We are just signing the token. So that makes it very important to transmit this token over SSL or TLS. Right? Use HTTPS for it. Now there are alternatives to it that we'll talk about for a little bit. The table here on the right side is a screenshot I took from the spec itself, where it says these are the different signing algorithms that are supported. I'm not going to go into details of each one of that, but we do the spec does support. You can just use a simple string. This is a secret kind of string, and sign your token with that, or you can use a private public key pair, anything like that. There's also that interesting none out there, the last thing in the list, when no digital signature is created. So in the case where you know that this token is already secured, you trust this party completely. There's a hacking possibility around that. It's recommended not to use it. In fact, many libraries don't support it either. Right. So there's a well-structured token then. Right. The other part of an access token is it has to be well-structured. This is what the headers and payload they provide us. And when we look at payload, JWT spec calls them as claims. All right. So claim is, in JWT terms, is what we call as payload here. And there are three kinds of claims that we can put. There's a registered claim, a public claim, and private claim. Registered claim are basically keys on that payload, on that token, which are defined in the spec itself. Okay. Things like issuer, subject, audience, expiry, and all these different items. They are defined in the spec itself. They are registered by the spec. So we should not use these key names, basically. So issuer is who issued this JWT token. Subject is what is this issuer trying to do. Now this is where you can restrict certain APIs from doing only post calls on your secure API, or do only get operations, or only some specific operations. That's how you can restrict or limit that. Right? Who's the audience for it? In this case, your final service is the audience for it. And we'll look through some of these use cases. Expiration time. When does this token expire? Just like cookies, right? Not before. It's for the part where a token may be issued, but you cannot use it before some specific time. If there's a use case. Personally, I didn't see a use case why I would use that, but it's out there in the spec. At what time it was issued, right? That's out there too. Now you may want to consider the mismatch in the clocks, a certain degree of skewness in there. That's what it counts at. And JTI, JWT ID, it's an optional thing to use. We don't have to use it. I've never used it myself, but if you are expecting multiple JWT tokens from the same client, and you want to use a specific one, you can use this ID. But all of these claims, though, all of these entries are completely optional. We don't have to have them. The spec does not mandate you have them all. Right. Public claims. Right. The example here in the purple is not an example of public claim. It's just a screenshot from before. But public claims are basically names like first name, last name, nonce, anything like that are very common out there. And they are defined in this IANA assignments page. Right. So if you are to put first name, last name kind of things, you may want to consider using these specific names. You can put your own as well. It doesn't really matter at that point. But if you're using well-known, well-defined APIs like Google API or Facebook, Dropbox API, anything like that, or if you're building one of that kind, which will be highly public, available outside to the world, you may want to consider using these public claim names. Right? And private claims are the ones that you build on your own. This is basically your own key value pair, any key name that you want to use. Make sure that it does not conflict with any of the registered or public names. That's really what the mandate is. But it's agreed upon by the producer and the consumer, right? And they know exactly what they're talking about. So again, a well-structured token in this way for JWT is where there's registered claims, public claims, and private claims. They're basically key value pairs in a JSON. You can have nested structures as well if you want to as part of your private claims. No qualms about it. Spec doesn't say anything on that front. Right. There's a header as well, which is well structured. Unfortunately, is like very small. As a specification calls out, there are just two fields in there. There's the type of the token, and there's the algorithm. Now, type of token is interesting. It says JWT here. But since there's a field, it implies that there are more kinds of tokens we can do, right? So we'll talk a little bit about that, not a whole lot. And then there's the algorithm. What algorithm was used to create this token, to sign this token, right? One of those in the list before. Right. So that makes up the header and the payload part of it, right? And essentially, that's where it ends. The JSON Web Tokens that way is a very simple data structure in the end that is defined out there for this access tokens, federated authentication kind of use cases and everything, right? So it's basically a simple JSON data structure. That's all it is. It is compact, right? It can be as compact as you want. It can be very small. They have kept the key names for those registered fields like issuer and all to be 3 characters only. Thinking about compact tokens. And so should you. You should also look at that. How big is your token? So we did run into this issue where at one point our token was so big and we were using Spring Boot and Spring MVC. And either it was Tomcat or Spring, one of these two, they did not process the entire token and it stripped it out. So we may want to keep an eye on the size of that token though. None of these specs out there, they say what is the maximum size of the header we can use, although 16K is usually considered to be a good enough size. So what about building some use cases with this, right? Don't really have a code example at this point here. It's still a few more talking points. But what different use cases we can build? So again, a login use case. Very similar to the one we saw before. I've just condensed those 3 sequence diagrams into one, so it's exactly the same. But in this case, where you have a browser where the user is going to log into the server side, so we're creating an access token, keeping it on client side and all that. In this case, your issuer can be your client. So if your API is going to be used by, let's say, your JavaScript-based application and a native app and a very smart thermostat or a Raspberry Pi application or something, these are the different issuers. You can identify them differently and say that if the token is sent by one of these devices, I want to use it differently, right? The audience is your API, your web server. Right? That is the audience for it. The subject, in this case, I've said it is a server. Basically, I'm allowing every operation on it. But you can build whatever string you want out there. You can say that this client is allowed to do just get calls from my API, or it can create or do post calls or anything. Expiry time, I've said 15 minutes. It can really be anything based on your use case, right? But after that time, if that time has passed, the server can reject that token outright. The payload, your private claims in this case, can be your session data. It can be in an encrypted form. It can be just in simple plain text form, completely, open. You can build it anyways, depending on your use case. Right? But that's what a typical login logout flow might look like. This is how our token might look like. What about calling REST APIs? Let's say you built a REST API layer, the next $1 million product and everything, and now you want to consume that API from another API, right? So from one JVM or the other, from a server-side call, essentially. One service calling into the other. Hopefully this is readable up there, but I'll read it out. First thing that it says is service 1, the other is service 2. And what it says is the service 1 creates a payload. In this situation, the way I would build it is that service 1 has a private key and service 2 has a public key, where the first service, the consumer side of it, can sign the token with a private key and give it to the service number 2, the receiving end, where it can verify that token using the public key, right? So that way we know that, okay, we can verify the integrity of that token very well. In this case, the issuer is service 1, the audience is service 2, and again, depending on your use case, certain methods or certain cases can be allowed on it, right? Optionally, you can set expiry time on it too. The way I've built it is that I've kept that expiry time to be very small, thereby mandating that every request has a new token. We are not reusing tokens at that point. And the payload can be, again, anything. It can be an encrypted form of your payload. If it is your post body, you may want to just create an MD5 of your post body and stick it in there just for further integrity. Federated authentication, or OAuth2-like use cases, right? That's really where this access token started, getting popular anyways, right? So in this case, you have an intermediate server, which is your auth server, right? You have a browser side or service app, and you have your actual service that is, processing the data. The issuer in this case can be that authentication server. This is how APIs around Google and other GitHub. So when you see that login with GitHub or login with Google kind of situations, this is the kind of scenario that happens where these apps are your authentication apps. They log you in, they give you a token. That token is given to your app on the browser side, and now you can use this token back and forth, right? So your browser is going to use that token, call the service side, because that audience is your service. And the expiry time can be TBD. It depends on again, your use case and what the auth server is prepared to give you. Google APIs, for example, they can give you access token for up to 24 hours. Right? And again, the payload can be some specific information about the user in encrypted form, or depending on the use case. So Google may, this is where these authentication server apps can say, you are allowed access to only, let's say, photos, Google Photos, and nothing else. Right. So we can build many more use cases of these kind, right? Again, so JWT is just a simple data structure, right? You can use it in many different ways, whatever fits your use case. About the code, right? I'm not going to do any live coding. I have some examples, some code in my GitHub repository, which I'll share the link at the end of this presentation. But you don't want to build these tokens by yourself, right? You want to use some libraries out there. So jwt.io is, again, where you would want to go and check out the libraries that are available, popular out there. So there's plenty of them. I've taken 3 screenshots. One is a Java, another is .NET, another is node.js. And there are these libraries that you can use to generate tokens and then to verify tokens. What it shows here is that the Node.js library, it does not support the checks around issuers and subject and expiry and all these things. The .NET and Java libraries, they support all of it. So make sure you check that out before you pick a library of your choice. Right. The spec also does not call out for things like rolling keys or anything, but that's something you can build out on your own. Some of these libraries, they support for rolling keys. Rolling keys in the sense that, let's say if I have my service, which is consumer, and another service, which is the producer of data, right? And service 1 wants to talk to service 2. And I want to sign my token with a different private key every time, just for that extra layer of security, right? So if I have 3 keys on the service side and 3 keys on the client side, and I want to do a round robin and use the next key out of that list on every access, I can set something called key ID on there, which is just the value of like 0, 1, or 2, the position or something. And then on the verification side, I can use that key ID, fetch the right public key or the secret, and verify token using that. So a lot of libraries support those additional things as well, which are not part of the token, the spec. So here's one example of that token creation. This is JavaScript Node.js code, where the data to encode is my key 1 value 1, key 2 value 2. Just it is my private claim names, right? And I'm using this library called Json Web Token. If it's readable up there, it seems like. And it's not readable down here, actually. And here I'm signing my token using just a simple string called this is a secret, right? So there's no private key, public key situation. I'm just, this is a very simple example. And then I'm using the jwt.verify method of that library to verify the token with that same secret. And of course, it will be able to decode that result, and I can console.log it out. But if I try verifying that token with a secret down here in the try block, which is not the right one, then it will throw an exception. So my output will look something like this, where it's too long to read. The first line up there, it is that payload that I'm setting. The second is the encoded token, and then finally the token decoded out. So nothing surprising, nothing new over there, right? So there's some more code in my GitHub repository, and last night I started adding some code examples around AngularJS, and I was feeling very adventurous, started trying out Angular 2, and things didn't really go right as I thought. So it's not out in GitHub yet, but I'm going to add it this weekend. But then I have some examples out on GitHub. There's one for rolling keys. That's a Java example. There's one that is about expired token, which is in Node.js, in which case I create a token with just 2-second validity. Say expires within 2 seconds. And then I try to verify that after 5. And of course, it will fail. And then there's also a trial on that hacking of no algorithm thing, which is kind of interesting. The issue is some of these libraries, they may have implemented this none algorithm in a way that if, as an attacker, you just go and change the algorithm type to none, the library will say, okay, this token it has no signature. I should not even validate the signature. Just go use it. More libraries have taken that feature out now. It's interesting to check that out. So when we talk about information security, right, there's this CIA triangle, as they say it. I did not put them in the right order here. But it calls out for 3 things, right? Information security, about confidentiality, availability, and integrity. You want to make sure that your data is confidential. No one else can see it. It is available when you need it. And it is strong enough, it has integrity enough so that if someone tampers with it, you know it was tampered with, and you can reject that token outright. Right. So JWT brings integrity into the equation, right? Because it is signing again and not encryption. It does not provide availability for sure because it's a very temporary thing, and it does not bring confidentiality in there at all. That's where we can use something like JWE. It's another specification, another topic for some other time. But it talks about encrypting the entire token, not just signing it, but encrypt it and make it available. Right? So there are options like that out there. And speaking of JWE, there are some other related specifications out there too. So this whole thing about JWE came out of this JSON object sign-in and encryption group within IETF. And they came out with these few specifications, JWS, JWE, K, and algorithms, which is the one we saw a screenshot from. But it's pretty interesting. It's good to see. JWT is the most popular. The other ones I have not really seen much libraries or support out there. There might be some which I just didn't stumble upon. But out of that, JWE is again the most intriguing one because it encrypts the entire token. And it also has a way to provide that key on the JavaScript side and all that, which is, again, it can be a tricky thing to do. So drawing down to the conclusion, I'm just around at 45 minutes, which is not bad. The key points, again, it's an open standard. It's a simple data structure. It has nothing more complex to it. Cookie specification, for example, it defined the structure and it defined these headers and how it should use it and what should the user agents look like, that 50 cookie limit and all these things. JWT spec is very much more simple. It is this data structure and that's all it is. It doesn't say how to use it. But that's where a lot of complicated things can happen, right? It's a simple data structure. When you start talking to other groups and other developers and other engineers in your teams, you guys will have opinions on what should be in that data structure, what not, and that's where a lot of interesting conversations will happen. They are compact, self-contained structures, base64 encoded, right? And again, signed and not encrypted. That means you should use them over HTTPS. Anything less than that, not a good idea. And JWTs are meant for checking the integrity of that payload. It does not provide for confidentiality or anything. And all that said, cookies are still good. It's not like we shouldn't use cookies. I mean, they do have a lot of good use cases. And not only your application-specific use cases, but you'll have things in your infrastructure where you may have load balancers or proxies or these different devices setting cookies for routing purposes or for stickiness and all that. So cookies are still good, and they should still be used. JWT is just a very compelling alternative. So you're building your apps in cloud or in data center, you can work with them if they have different domains, if they're using different user agents, mobile apps, anything like that. And that's my caricature, thanks to Star Trek. It's pretty awesome. But this is my contact info. And the last link in there is my GitHub repository for this presentation. It has this PPT in there and the code examples and all. And reach me out at my email address up there with any questions, anything you need to know about what is JWT or just microservices and all that. I'm kind of feeling pretty excited about those things. So that's it. Questions?
I have one over here. Sorry. You touched earlier on storing your JWTs in local storage or JavaScript variables. It's probably worth pointing out that both of those are susceptible to cross-site scripting attacks and also make loading static resources really difficult. Like maybe you only want someone to be able to download a PDF if you're logged in. And if you're just
Yeah, that is an option too. JWTs can be stored in a cookie, and that way it's available on these static resources and other use cases. That's absolutely an option too. Yeah, good point. Agreed.
Thanks.
Yes.
You talked about expiry and use before. Is there a mechanism to support invalidating the token in that logout use case?
So expiry and not before, it can be used to expire the token in the logout use case. It can be used for logout use case, right? With cookies, we rely on the browser or the user agent to expire that cookie out, right? Which if it doesn't, or if it does it at a different time than when it happens on the server side, it can cause problems. In this case, the client, the browser, does not really have to expire it, just has to simply stop using it. And even if it uses it, the server side can reject it because the expiry time has passed.
Within that window, if it like expired 15 minutes later and someone got a hold of it, they can still continue to use it and the server would find it valid.
They can still continue to use it, yes. So if you got hold of that token, the user, some other user can use it as long as you're not changing anything in there. But that's where, if depending on your use case, if you have one service calling the other, you can just set a very low timeout or very low expiry. So we used a 3-second expiry so that every request will have a new token. If you try to reuse it, not allowed. You can also add in nonce, right? So that way, if that token is used more than once or more than certain times in a given specific time frame, you know that there might be something wrong. Yes.
You tend to see where people have the JWT client and server libraries, where you pick an algorithm that you use. Do a lot of people start to use, or I guess you're allowing clients to pick the algorithm that they want to use versus dictating that it's HMAC 256 or 3 to 4 or whatever it is. Is it something that they tend to see that's the purpose of that? Obviously, then the none came in with problems where they both allowed none to come through and could pass anything in.
Right.
Is that basically the choices? It lets your client choose which algorithm they want to use?
Yes, that is one of the things. But at the same time, there is also a debate around should there be an algorithm at all, right? So I think that's what you were touching upon, where if the client and the server knows, and as developers, you've already done that handshake before actually starting to use tokens, you know that, okay, this is the algorithm we have agreed to. We don't really need it as part of token. Yep. All right. Am I missing anyone? I think that's it. Thank you. Thanks for coming. Enjoy.